This video covers Module 4 Part A, Analysis of Tutorial Attendance Data. In this video, what I want to do is use some of the past AMB 201 attendance data in order to start to discuss some of the types of analyses that we might want to do in order to examine the attendance performance link. The attendance performance link is a concept within an academic setting that relates to the idea that attending more classes or going along to more classes will lead to better academic performance. And I'm sure we've all encountered this in high school and in university, where your teachers and lecturers have explained that coming along to classes is important if you want a high score or a high grade. And often we don't see a lot of evidence or analysis of data to support those claims. Those claims can very often be based on someone's intuition or anecdotal evidence, just their own personal experience, without a real understanding of whether or not the data does actually support that. So in a class like AMB 201 that's very much about research and very much about data, what I think is it's important to start to look at the actual evidence for those claims and how we might analyze that to see whether or not they're valid claims. So if you've been going to classes in AMB 201 across the semester, one of the things you would have noticed is that your tutors have been taking attendance. Attendance isn't mandatory in our classes, but we do collect that data to help inform some of these activities and some of these discussions that we have, and that's very much what I'm going to be doing in this video. So the analysis technique that we're going to be talking about is correlation, which is examining how one variable appears to relate to another, or how two variables are associated. And I'll go through some ways we can think about correlation, and that'll serve as a nice primer for correlation as we'll talk about with our survey data analysis for the quantitative project. So as a starting point, what I want to do is discuss the attendance performance data from students who completed AMB 201 in 2017 semester 2. So on the figure here on the screen, what you can see is a graph or a chart showing on the x-axis here, or this horizontal axis, number of tutorials attended ranging from 0 to 10, so we can classify students based on number of tutorials attended, and the overall grade or mark that they might have achieved in that unit. So this is a percentage, so a mark out of 100. We can use this to start to really look at if there is a relationship between those two things. Before we get to that though, one thing that I can point out is that the average score that students achieved that semester was 65.3%. So it's a fairly decent score. It's just over that borderline or that threshold of a 5. So if you're wanting to know whether or not you'll perform, how well you might perform in AMB 201, and you want to know the average, we could say that the average score is 65%. Some students though, they want to know how they can perform well or how they can avoid performing poorly. And we do have students ask us at the start of every semester how well they're likely to achieve. So some students might say, I'm not going to be able to attend many classes because I work a lot. Is that going to impact my performance? And if we haven't collected attendance data, then we can't really make a valid judgment on that or an evidence-based claim from that. All we can say is the overall average for the class is 65%. We don't have attendance data, so we shouldn't be making any claim beyond that. Similarly, if someone says, I'm going to work really hard, I'm going to attend all of the classes, is that going to give me a good score? Unless I've collected attendance data, I can't tell that person, yes, it's going to. I can say, probably, based on my intuition, I think attending more classes is going to give you a better score. But if we don't have the data, all I can do is pretty much say to that person, the average score is 65%. That's our the best guess at what students will get. We know that's not always ideal because there's a lot of variability in students, but that's the best we can do if we haven't collected that data. Once we have collected attendance data, as you can see on the screen, we can start to give more informed responses. So I can say, well, based on past performance, students who attended 0 classes on average got a score of 49%. So there were scores above that, scores below that, but on average, students who didn't attend any classes got a score of 49%. So probably you want to attend some classes. Similarly, if we look to the other end here, we can say that students who attended all 11 tutorials, so in 2017 semester 2 there would have been 11 tutorials, the average score there was 73.5%. So again, we would have got higher scores and lower scores. The average for that group of students was 73.5. So looking at that, we could say beyond just the average of 65%, it appears that there is an association between tutorial attendance and student performance, such that the more tutorials you attend appears to be related to a higher overall score in the unit. It appears to have this positive, there appears to be a positive relationship. Whenever we see one variable increasing as the other one also increases, so both variables increasing, we get this upward diagonal trend, and we call that a positive correlation. It appears to be a positive relationship between those two things. Really, or technically, if we're looking at this data, it's not correlation data. Correlation data looks like a scatter plot, whereas this is just averages for each of the number of tutorials attended. But in general, we see that positive overall relationship, where attending more tutorials appears to be related to getting a higher overall score. So we would call that a positive correlation, and we get a, if we were to depict it as a scatter plot, we'd see a relationship somewhat like that. We could also potentially get a negative correlation with tutorial data. So if it was the case that the more tutorials attended, the poorer students scored in their overall result, we had this downward trend across number of tutorials attended, we'd call that a negative correlation. And that would be the case if coming along to tutes was just wasting your time and you're actually being prevented from studying and instead engaging in mindless activities or activities that didn't relate to the unit. So we would actually see a relationship like that, and we'd call that a negative correlation. So as one variable is increasing, as number of tutorials are increasing, the other variable is decreasing. So this downward trend like that is called a negative correlation. This next slide here illustrates the different types of correlations and strengths of correlations that we can often get. So across the top here you can see a positive correlation. We've got this upward trend in the data. So as one variable is increasing, the other one is also increasing. And the points in the scatter plot are quite closely clustered along that diagonal. So it appears to be a fairly strong positive relationship. In this one here to the right, you can see it's a strong negative relationship. It's a clear diagonal line going downwards, but the points are also fairly tightly clustered around that diagonal. As relationships get a little bit weaker, so it's the case that there's more scattering of those points, we might just start to see a scatter plot that looks like this, and we can still see a somewhat positive trend here. We can still see an upward trend, but that trend, that trend is a little bit weaker. The data points aren't quite as closely clustered. So even attending fewer tutorials, we see people can get quite a high score, and students attending all tutorials can get quite a low score. So we'd say this is a much weaker relationship. Where the data points don't appear to follow any upward or downward trend, and they're not closely clustered along any diagonal, we can start to say that there's an absence of correlation. It doesn't matter how many tutes you attend, it doesn't appear to be related to the score that you get in the results. So we can say there's an absence of correlation if our data looks something like this bottom yellow one. When we're talking about correlation, then we can talk about three things as shown here in the text. So we can talk about the direction of the relationship, if it's positive or negative. We can talk about the strength of that relationship, and that really relates to how tightly clustered those points are along the diagonal. And when we talk about that statistically, we talk about that as a value between 0 and 1, or an absolute value between 0 and 1. When we're talking about a positive correlation, a very positive correlation, what we would say is a strong positive correlation is closer to 1. The weaker that correlation becomes, the closer to 0 it becomes. And with a strong negative correlation, we'd say that would be close to -1. And then the weaker negative correlation, closer to 0. And then we've also got the significance of that relationship. We'll talk more about this later in the module, but a significance level essentially refers to how likely it is that any apparent relationship was just due to random sampling error or just due to chance. So it might appear to be a relationship, but how likely is it that that relationship just occurred due to chance, or just occurred based on the data that we collected? So a significance level is probability that indicates how likely it is that that relationship is just due to chance. So these are the three things that we look at when we're talking about a correlation. When we run a correlation analysis in a package like Excel or a package like SPSS, and SPSS is the package we're going to do our analysis in for our survey data for AMB 201, we get very specific statistical data from it that corresponds to the direction, the strength, and the significance of those relationships. When we run a correlation, we get a correlation matrix, and it looks something like this. So here you can see attendance in this top row, and then marks indicated in the bottom row, and they're crossed with attendance and marks here. So this is essentially a correlation matrix that mirrors itself. So this score and this score is the same, and this score and this score is the same. So really we only need to look at one. Attendance correlates perfectly with itself, so you can see here that's a very strong positive correlation. That makes sense because the more classes you attend, the more classes you attend, right? So it's a bit non-meaningful. What we're really interested in is the correlation between the marks that people achieve and their overall attendance. So it'd be this cell. Or we could look at that cell, it's the exact same thing. This first row corresponds to our Pearson's correlation coefficient, and this tells us the direction of that relationship. So that you can see this is a positive number, so it's a positive relationship, and it's a moderately strong relationship. It's 0.418. So a low or a weak relationship might be something like 0.007, and a strong or very strong relationship might be 0.89 or 0.915 or something like that. But this is in the middle, so we're saying that we've got a moderately strong positive correlation. So the relationship between attendance and marks achieved is moderately strong at 0.418. Our significance level here is very low, it's 0.000, so that tells us that the relationship that we're observing in our attendance data is probably not due to chance, because our significance level is very low. So you can read that as a probability. There's virtually a nil probability that that's due to chance. And then this bottom row here corresponds to the number of participants' data or individuals' data that fed into that analysis. So there was 365 students that semester whose data fed into that analysis. So what would data look like if we had a very weak relationship then? If we were to look at something like, instead of tutorial attendance, the relationship between the letter or the first letter of someone's surname and their mark that they achieved, you could imagine that we wouldn't expect much of a relationship. It doesn't matter if someone's surname starts with A or B or T or Z, right? We would still expect them to be able to get high or low marks. So here you can see the final marks that people have achieved, and across the bottom here I've indicated numbers corresponding to the first letter of each person's surname. So people with surnames starting with A would be grouped into this one category, and starting with the letter Z grouped into this 26 category. And you can see the results here. This is data combined from a couple of semesters a couple of years ago. I don't want to be too specific about which semester it was in case you know someone with a surname beginning with a certain letter. So you can see here there doesn't appear to be an upward trend or a downward trend. It appears to be almost no relationship, and you wouldn't expect a relationship. So someone's surname shouldn't really relate to how well they achieve a score in that unit. When we examine that statistically, right, that plays out. You can see the Pearson's correlation coefficient between someone's last name and the mark they achieved being very low, 0.032, so it's a very low correlation. The significance level is very high, so there's a very high probability, so 54.4% probability that any sort of relationship is just due to chance, and there were 751 participants' data that fed into that. So as I said, that's a few different semesters combined. So that's what a null or a zero correlation would look like. All right, so then going back to that data, what we can say is that there does appear to be a positive correlation or a relationship between attendance and overall performance in AMB 201, and that's moderately strong. What we can do, though, is start to question, well, is that truly attendance that's leading to overall performance? So we could certainly say that there are alternative explanations. So, for example, it may be that people who are more conscientious or who have more available time, so potentially who aren't working, have more time to study and therefore achieve higher grades, and can also get along to more tutorials. Students that are working and don't have time maybe can't study as much and can't attend tutorials, so therefore they get a lower grade. So it may not be tutorial attendance per se that's causing that trend. It may be something else, and it's when we see the data in this sort of format and see the analysis of that data that we can start to really judge whether or not we believe the claim or whether something else might be at play. Another thing that could certainly play into that is that it's not attendance at tutorials that's leading to better performance, but it's access to material or access to learning content. So if people are provided with access to learning content online, for example, and they make use of it, then attendance at tutorials may become irrelevant. So what we can do beyond just thinking about the claims that are presented to us, when we think about alternative explanations, we can start to change things and see whether or not those same patterns hold. So one of the things that we did in semester 1 in 2018 was start to provide a lot more online learning content in AMB 201. So we provided study questions, guided study notes, study quizzes, and we also provided the lecture recordings in bulk, so people could start to sort of binge watch that content if you like. And that can certainly play into the types of grades that people achieve without attending tutorials. So we can come back and look at whether or not we still get those same correlations for 2018 semester 1. I can tell you in 2018 semester 1, the overall average after we started to provide that additional content was a little bit higher. So instead of 65, we got almost 67% as the average in the class, and we still see this positive relationship between tutorial attendance and overall grade that people achieved, but what we start to see is that it doesn't appear to be quite as strong of a correlation. So rather than getting scores right down here for the 0 attenders, what we see is that those students started to perform a little bit better. Students attending all tutorials also had an overall average increase in their grade of about 2 or 3%. So we see this overall positive trend, but it's perhaps not as steep once we start to provide that additional content. You can see that in the data here, where we can see the relationship between attendance and the overall mark that people achieved as being 0.348. Now if you remember the data from 2017, what we said is that the correlation there was 0.418, which is moderately strong. For 2018 semester 1, the correlation fell down a little bit, so it was 0.348. So this is still a moderately strong relationship. There's still a fairly good correlation between attendance and overall performance, but it's just not as strong as it has been in the past. And you can see that here because we've got a fairly steep relationship in 2017, and then in 2018 semester 1 that relationship becomes a little less steep. So when we look at the data for these sorts of claims and we consider changes that occurred across these time points, we can start to really make some judgments about whether or not they're valid claims. So because we're getting less of a correlation where these people not attending classes are also starting to do a little bit better, we can say that it's perhaps not solely attending tutorials that's important, but it's the ability to access material. So in the past, perhaps going along to tutorials was the best way to access material, or perhaps the only way to access learning content. Once we start to provide that online, and online in a really flexible and effective way where students can take advantage of it, we start to see that relationship fall away a little bit. It's still there, it's still fairly moderately strong, but it has fallen away a little bit. So that's really showing that there is value in that online provision of material, and goes back to the whole rationale behind AMB 201, where we look to provide that flexibility of learning. So even to summarize all of that, even basic statistics like correlation that really just show us the relationship between two variables can be very useful, and particularly very useful where we start to compare across time or across two different groups, for example. And hopefully what I've done with this video, although it's about attendance data, I think it's something we can all appreciate and relate to. So hopefully that serves as a nice reminder of correlation if you've dealt with correlation before, or a nice introduction to correlation, but certainly a primer for dealing with correlation in our upcoming survey data analysis. So in this video we've covered a little bit of tutorial attendance feedback. We've gone through correlation as a primer. Hopefully that's an introduction or a refresher. The next video we'll start to look at data analysis in terms of cleaning the data and providing descriptives in relation to our overall survey data that we collected for the quantitative project.